This is section 4 of the ACT Math Manual, section 4, VITA. VITA is the first major math technique under the tin category, throwing in numbers. We have 3 tin techniques. VITA is the first. We are going to do nidus and general tin in later sections. So in terms of VITA, the first thing that we need to know is when we can use it. So we're going to need a little visual tip-off clue, and fortunately the technique itself is named after, or I should say is an acronym for, the tip-off clue. The tip-off clue is variables in the answers. And as I said, that is exactly what VITA stands for, variables in the answers. It is just an acronym for the tip-off clue. So when we see variables in the answer choices, so you can look at number 8 and number 18 at the bottom, and in fact every question in this section, you can see variables in the answer choices. The variables in the answer choices is how we know that we can use this technique. I will say the technique will very, very frequently work and be the easiest solution on a lot of questions with variables in the answers, but it will not always work, and it may not always be the easiest way to go on certain questions, but it will save you in a lot of cases where you can't see the quote-unquote correct or school method of solving the question. So the VITA steps, let's go through these and jot them down. So step 1 of VITA is simply to list all variables or unknowns. List all variables or unknowns. Step number 2 is going to be to throw in easy numbers. So you're going to list your variables, you're going to throw in easy numbers. When we say easy numbers, generally we mean 2, 3, 4, 5, maybe 10, but simple integers. There are going to be some questions where you want to possibly throw in different types of numbers, maybe fractions, maybe negatives, maybe big numbers, but generally 2, 3, 4, 5 are going to be your best bets. You do, however, want to definitely avoid, on most VITA questions, you want to avoid using 0 and 1, and we'll talk about why that is in a moment. But 0 and 1, you do want to stay away from those. Once you have thrown in your numbers, you are going to solve using your numbers. So you're going to throw in your numbers, you're going to solve, and you are going to box your numeric result. So box your numeric result. So again, you're going to toss in your numbers that you have chosen here in step 2. You are going to solve the question using those numbers. You're just going to be doing mainly arithmetic, adding, subtracting, multiplying, dividing, and then you are going to put a box around the number that you get. And then step 4 is to check all answers. Now what I mean by check all answers is basically you're going to throw the numbers that you have chosen in step 2 into the answer choices to try to find the value that you had boxed. In other words, you're converting your answers from variables to numbers to find out which answer choice matches the result that you got in step 3. So I am going to go ahead and highlight the main parts of these guys. So step 1 was list, step 2 was where you were actually throwing in, step 3 was solving and boxing, and then step 4 was checking all of the answers. And we'll talk about why we have to check all of the answers in a moment. So let's look at number 8. Now, before we start this, I do need to say that the vast majority of students who are confident with their exponent rules will be able to look at number 8 and solve it in a matter of probably seconds using algebra using exponent rules, and that's perfectly fine. If you feel like you can do number 8 the correct way, you can go ahead and do it that way on the day of the test. I'm using number 8 here as a soft example to get started with the technique. So what we're going to do is we're going to pretend. We'll play a little game of pretend here, and we'll say that you were walking into the test and you tripped walking up the stairs to the classroom and you bumped your head, and fortunately you're okay, but the part of your brain that deals with algebra and all of your exponent rules is fried, and you don't remember your exponent rules. You don't remember what you do when you multiply x to the 5th times x to the 9th. It's gone. So you would need a different way to do this question, and the way that you could do this question is, as we just talked about, using VITA. We have variables in our answer choices, so we can use this tin technique. So here's the way this would go. So first of all, what are they asking here? Oops, that was a little, there we go. So that's what they're, let's try that one more time. They are asking what 3x to the 5th times 7x to the 9th is equivalent to. So what we're going to do is we're going to do the 4 steps. I'm going to make them visible. So number 1, we're going to list our variables. Well, that's very simple. We just have an x. Step number 2, we're going to throw in easy numbers for that variable. We're going to use 2. We said 2 is very easy. That's what we're going to use. So now what we do is basically let the calculator do the work. So now we have 3 times 2 to the 5th times 7 times 2 to the 9th. We are going to find our numeric result, and we're going to do that using the calculator. So we're going to go 3 times 2 to the 5th. We're going to multiply that by 7 times 2 to the 9th, and we're going to hit enter, and we're going to get this really big number, but that's okay because again we have a calculator, and the calculator is going to do all of this work for us. So 344064, 344064. And remember, we're going to put that into a box because we want to make that number stand out. We want to make sure that we know that this is the number we're looking for. So when we go to the answer choices and the day of the test, you should be doing this fairly quickly. We're going to do 10 times 2 to the 4th. We're going to find out that that's way too small, so answer choice F is gone. We'll cross these off as we go. F is gone. Answer choice G is 10 times 2 to the 14th, 10 times 2 to the 14th, so obviously that's going to be bigger, but let's see. Oh, that doesn't get us what we need. It gets us, again, something a lot bigger, but not quite. Answer choice H is 10 times 2 to the 45th, 10 times 2 to the 45th. Wow, that's way too big. Answer choice J is 21 times 2 to the 14th, and ding 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 ding, we have a match. So this guy is good. These two guys were out. And then answer choice K, 21x to the 45th. We know that's going to be bigger because the exponent is bigger than the exponent in answer choice J. So we know it's not going to work, but we're going to do it anyway just to make sure. Times 2 to the 45th, and that's way too big, and we're done. So again, what happened here is we were, for some reason, we had forgotten our exponent rules. Our algebraic skills were just not there for us, and we said, okay, well, we've got variables in the answers. We can throw in some numbers here. We found that when we throw in x equals 2, 3x to the 5th times 7x to the 9th equals 344,064, and answer choice J happens to equal that same number when we throw in x equals 2 to answer choice J. So that's VITA. We are, again, we're throwing in a number, we're solving the question arithmetically, and we're letting the calculator do a bunch of the work for us. Let's take a look at number 18. If you want to try this on your own, you can always pause the video, but since we're just getting used to this technique, I would suggest working along with me. So let's read it all the way through. Terry has $6 less than does her sister Jenny, who has X dollars. Terry does not spend any more money and earns $4. Which of the following is an expression for the amount of money Terry has. So let's go ahead and circle what they are asking. Money Terry has. How about that? So we are going to go ahead and list our variables. We have basically two variables here. We have a Terry and we have a Jenny, but we do need to remember that they tell us that Jenny has X dollars. So Jenny is actually equal to X. So we really can just do T equals and X equals. So first phrase here says that Terry has $6 less than her sister Jenny. So I'm going to make Jenny have 8. And since Terry has $6 less than her sister Jenny, that means Terry has 2, which is $6 less than 8. This says Terry does not spend any money and earns $4. That's the next phrase. So we're going to go ahead and increase this by $4. That means she has $6. And this says which of the following is the expression for the amount of money Terry has. So this is what Terry has, and that's what they're asking. So that's what I'm going to put in a box. Remember, whatever the solution is, whatever they're actually asking, that's what we need to have in a box, and that is what we're looking for in the answers. So when we go to the answers, notice we're throwing in the 8 because that's what we threw in for X, but we're trying to find 6. Well, answer choice F obviously doesn't work. Answer choice G is going to be 8 plus 2, which is 10. That does not work. Answer choice H is going to be 8 plus 10, which is 18. That obviously does not work. Answer choice J is going to be 2 times 8, which is 16 minus 2, which is 14. That does not work. And answer choice K is going to be 8 minus 2, which equals 6, and indeed that does work. So once again, we listed our variables, we threw in some numbers, we got a numeric solution, and we found that answer choice K equaled that numeric solution. I will say one more time, it is very possible that you would find number 18 to be fairly simple algebraically, and if that is true for you, that's fine. You could do that question algebraically. It's a number 18, so it's still among the relatively easy questions. We are doing these questions right now just so we can get our feet wet with the VITA technique on some easier questions. Now, there's a bunch of other notes that we need to know about this technique, a little bit of deeper information on the technique. So this is the following page, page 28. We've got VITA practice and additional points. So one additional point when we are VITA-ing is we will often see this phrase, this in terms of phrase. So you'll have in terms of, and then you'll have a variable that follows. And short story here is that I want you crossing off the in terms of as well as the variable that follows. So that you are focused solely on this right here. This question is just asking what is X. And remember, in VITA, what we're going to end up doing is we're going to end up finding a value for X. Let's say we find that X equals 16. So we would box that number, since that's what X is, that's what we're looking for in the answer choices. And this in terms of Y phrase is completely irrelevant. It's an algebraic phrase. It's basically ACT's way of directing us to solve algebraically. And since we're not solving algebraically, we don't really need that phrase. And unfortunately for some students, if they leave the phrase in, they get a little bit confused as to what it means and what they're looking for. So again, to avoid that confusion, to make things a little bit simpler, just cross off the in terms of and the variable that follows and just focus on basically what comes before the in terms of phrase. Here it's X. If we solve for X and we get X equals 16, then that's what we box. The next thing you might want to do, mainly when you're starting out with the technique, you might not find that you need to do this after you are an expert at the technique, but you might want to rewrite the question. Now, obviously, we're not really rewriting the question, so perhaps that should be in quotes. But what we're going to do is this. So let's take a look at number 4. We'll read it all the way through. VITA, it's an interesting name, earns F dollars per hour for H hours and then earns G dollars per hour for 3 H hours. In terms of F, G, and H, these earnings totaled how many dollars? So let's do totaled earnings totaled dollars. So how many dollars did the earnings total? So we have first of all this in terms of phrase here, which we just said we want to cross off. So we're actually going to cross off the in terms of, and then remember we said cross off every variable that follows. So we're going to get rid of that whole thing. Again, we're focused on the total earnings in dollars. So we have an F we have an H, and we have a G here. So that's step one of the technique. We're going to list our variables. F equals, H equals, G equals. And now we're going to start throwing in some numbers. So let's say F is 2, let's say H is 3, and let's say G is 4. So she is earning $2 per hour, and this is what I mean by reading it. That's a pretty bad wage, but so she is earning $2 per hour for 3 hours, and then earning G dollars per hour, which was 4 for 3H, and since we threw in 3 for H, this is going to become 9 hours. And that's exactly what I mean by rewriting the question. I mean crossing off the variables, crossing off the algebra, and writing the numeric substitution above those variables, so that now when we read the question again with the numbers inserted, things should seem really simple. This is now saying VITA earns $2 per hour for 3 hours. Well, if somebody came up to you and said that they earned $2 per hour for 3 hours, first of all, you would say you have to get a new job because that's just way too little money. And then second of all, you would say, okay, well then that means that person earns $6. And then the next phrase says $4 per hour. Ooh, big raise. $4 per hour for 9 hours. Well, that means that the person made an additional $36. 4 times 9. So this person made a total of $42. And since that's what the question was asking us for, and that's what we're going to be looking for in the answer choices, we box that number. And then remember what we do, we go to the answer choices and we find the one that equals 42. In this case, it's going to end up being J. I won't make you go through the whole process of checking the answers. We can just verify that this is 6, F times H, 2 times 3, plus 3 times 4, which is 12, times another 3, which is 36. So 6 plus 36 equals 42, and indeed that's the answer. Again, remember, normally you would have to go through all the answers and check all of them, but the bottom line with this example is that when you are getting your feet wet with the VITA, when you're just learning how to use the technique, you may want to cross off the variables in the question and write the numbers that you have used above those variables, and then reread the question, and hopefully things should seem pretty straightforward to you. Now, checking all answers. We had said in step 4 that we always want to check all of the answers, and the reason that we want to check all the answers is because we may get doubles. We may get multiple answer choices that kick out our box number. So for instance, we have this up here, we have this 42 in a box. There is a possibility that you're going to throw the numbers that you have chosen into the answer choices, and multiple answers are going to give you that 42. Take a look at number 29 here. Let's read it all the way through. For all positive odd integers n, how many positive even integers are less than n? So we're going to circle this whole thing. How many positive even integers are less than n? That's what the question is asking. This first phrase, some people get a little bit intimidated by the wording or the order of the wording here. For all positive odd integers, n is really just saying that n is a positive odd integer. That's all that phrase is saying. It's saying that n has to be a positive odd integer. So students will see the variables in the answer choices. They will say, oh, I can use VITA here because I have variables in my answer choices. They'll list their variables, which is step 1 of VITA, and then almost all students, because I have told them not to use 1, will start with 3 here. N has to be a positive odd integer. Well, 1 is the first positive odd integer, but I have said not to use 1, so students will go to 3. And then this question becomes, so I'm going to cross this off and I'm going to write a 3 here. This question becomes, how many positive even integers are less than 3? Obviously, in order to get this question right, you have to know your math vocabulary. You have to know what positive, you have to know what even, you have to know what integers means. So if you don't know those words, you need to make sure that you brush up on them. We do cover those words in an earlier section, so by this point you should know them. But how many positive even integers are less than 3? Well, the positive even integers less than 3, well, let's look at the integers less than 3. So I'll just list a bunch of them. Well, obviously these two guys are not positive. You should know that 0 is not positive either. You should know that 1 is not even. So it looks like this is the only 2, the number 2, is the only positive even integer less than 3, which means the answer to this question, how many positive even integers are less than 3, is 1. 2, the number 2, is the positive even integer less than 3, but that means we only have one number that is a positive even integer that is less than 3. So we're looking for 1 here. There are 1 positive even integers less than 3. So when we go to the answer choices, which we're ready to do now since we have our box number, we go to the answer choices. This is n minus 1, which is 3 minus 1, which equals 2. So obviously that doesn't work. B is 3 minus 2, which equals 1. So a lot of students who are not doing the technique the way they're supposed to be doing the technique might stop on answer choice B because they've gotten a 1. But remember, we said in step 4 of VITA that you have to check all of your answers. So we need to keep going. We can maybe put a check next to B, but we need to move on and check the rest of the answers. So answer choice C is 3 plus 1. This is 3 plus 1 over 2, which is 4 over 2, which is 2. So that doesn't work. This is 3 minus 1 over 2, which is 2 over 2, which is equal to 1. So now what we have gotten is doubles. We have gotten 2 answers that kicked out our boxed number, and that's okay. That doesn't mean that the technique failed or that you did anything wrong. It simply means that by the luck of the draw, we happened to choose a number for n that caused multiple answers to equal our box number. We will check E. This is 3 over 2. That does not work. So what do we do when we get doubles? The reason, or what we do when we get doubles, is we just start over. We basically just do the steps to VITA again, and fortunately we don't have to recheck all of the answer choices. We only have to check the 2 answers that worked initially. So again, remember that n was supposed to be an odd integer, so we use 3. We'll go to 5. The numbers less than 5 are 4, 3, 2, 1, 0, negative 1, negative 2. Well, remember we said these guys are not positive. These 2 guys are not even. So there are two positive even integers less than 5. 2 and 4 makes 2 positive even integers. So now what we do is we redo step 4, but like I said, you only have to check the answers that worked initially. So answer choice B, remember n is now 5. So this is 5 minus 2. That equals 3. Well, that does not equal what we put in a box. So we can now get rid of answer choice B. B fails when we choose that new number 5 for n. Answer choice D is now 5 minus 1 over 2, which is 4 over 2, which is 2. That does match what we put in the new box, which means our final answer is D. So again, if you get doubles, you just have to repeat the steps. You only have to recheck the answers that worked the first time, and almost always when you use new numbers, you will find that only one of the doubles will work. Now, by the way, doubles is the reason that we do not use 0 and 1 on VITA questions. Remember, we said we do not use 0 or 1 on VITA questions. Doubles is the reason for that. The numbers 0 and 1 will tend to produce doubles very frequently. If you throw in 0 or 1, you will find that many of your answers will double. 2, 3, maybe even 4 answers will come out equaling the same thing. So stay away from 0 and 1. The next page, page 29, calculators. One of the beautiful things of VITA, aside from the fact that it just generally makes questions a whole hell of a lot easier, one of the benefits of VITA is that we can use the calculator. The calculator can do a lot of our grunt work for us. And especially when things get messy, when we have let's say negatives, when we have exponents, when we have when we're subtracting negative numbers, when we're raising negative numbers to exponents, to the second or to the third. When things get messy, the calculator can really come in handy in a couple of different ways. One of the ways is if you do have a store function in your calculator, and all of the TI graphing calculators have this little store button here, that will tend to come in handy on these questions, and I'll show you in 1 second how. So let's take a look at number 31. Again, this is a question that some students will look at and say, well, that's really easy to solve using algebra, and if it is for you, that's perfectly fine. If you're really solid with your exponent rules and with your algebraic manipulations, then you can solve this day of the test with algebra. We're going to do it here with VITA to get more practice with the technique. So we are going to start by, as we said, we're going to list our variables. I've already circled what the question is asking. We're going to list our variables. We're going to make a equal to 2. And here's what I'm going to do. Instead of trying to do this all by hand and writing it all down, I'm going to go to my calculator and I am going to hit 2 and then store and then X and then enter. And what I have just done is I have made this X button. When I type this X button and hit enter, I've made that X button equal to 2. I will say before we move on, do not worry when you go up into your Y equals screen, into your graphing screen, and you put an X in here. Let's say you wanted to plot the line X plus 2. This X does not have a specific numeric value. This X is just your regular old X from the XY coordinate plane. So what you have just entered here does not equal 4 because you programmed this button as 2. So again, the X that you see up here is separate from the X that you see here. So don't worry about screwing up your graphing stuff by storing a value for X. It will not mess anything up. So what I have done now is I have made this button equal to 2, and watch what I can do now. I can actually type this numerator in exactly as it appears on the page in front of me with parentheses and exponents and everything. So 2x squared cubed plus 3x. I'm just using x for a, by the way. I actually could put an a into my calculator, but it's much easier just to use the x key. Minus 5 parentheses x squared and parentheses squared. So that's the numerator. I have just entered it exactly as it appears on the page in front of me. I'm going to hit enter. Boom, my numerator is done. What the calculator just did is it substituted, so 480, it substituted the x equals 2 in for those x's that I typed in, and it gave me an answer, and I didn't have to worry about the order of operations, and I didn't need to worry about this negative. I didn't need to worry about any of that stuff. Now divided by 2a, well, that's just 4, so that's easy. So 480 divided by 4, I'm going to go in my calculator and I'm going to do that 480 divided by 4, and I'm going to get 120, and now I've done all of my steps of VITA. So I have my boxed number, I have the 120, so I'm ready to go to the answer choices. I could just do these answer choices in my calculator the same way that I did before. So I could do 3x minus x cubed. That's answer choice A. That equals negative 2. So that guy's gone. I could do 4x to the 4th minus x. Oops. That's one of the things you've got to be careful of. So 4x to the 4th, I need to hit the right arrow, minus x cubed. Now keep in mind, if I was doing this with a regular calculator, it would actually be going a lot more quickly. So that was 56, so that's obviously not right. Answer choice C is 3x to the 5th. I've got to come down out of that exponent, minus x cubed. So that guy equals 88. So we are getting larger, but we're not quite there yet. Then we have 4x to the 5th minus 11x. Okay, I did it again. Definitely one of the dangers of these calculators. Minus 11x to the 3rd, that guy is going to equal 40, and then answer choice E is 4x to the 5th and we are taking out x to the third, and we get 120. So answer choice E gave us, I don't know why I crossed that off, answer choice E gave us the value that we needed, and we are done. So look, the point there is that if you do have a fairly complicated algebraic expression and you have some negatives and some exponents and you are nervous about making some kind of a careless mistake with your arithmetic calculation, I would suggest using your calculator and possibly even using the store function, and then you can just enter things exactly as they appear on the page in front of you. Multiple variables and dependence. So one of the things that you're going to need to do when you see a VITA question with 2, 3, or more variables. Here we have an A, we have an X, we have an R, we have an S, so we've got a bunch of different variables here, and those variables are part of an equation. You have to understand that there's a difference between a question that says something like X and Y are integers and a question that goes on to say something like X and Y are integers where X equals 2Y squared. In the first case, if we just say X and Y are integers, then we can pretty much throw in whatever the heck we want for X and Y. The poor VITA, who's making only $2 an hour, this question was actually a very good example of one where we had 3 variables, F, H, and G, and we could just throw in whatever the heck we wanted for them, 2, 3, 4. It didn't matter. These variables did not depend upon each other. It wasn't like when I threw in 2, I immediately know that H had to be 3 and G had to be 4. But on a question like this, if I were to say that X equals 2Y, well, I cannot just willy-nilly throw in whatever the heck I want here. If I throw in X equals, let's say, 3, well, then Y is going to have a predetermined value based on that 3 because X and Y are related in an equation. So the first and most important point is when you have multiple variables, you have to check to see if those variables' values are dependent upon each other. And obviously, if you see your biggest sign, your biggest giveaway that variables are dependent upon each other is if you have an equal sign between them. If there's an equal sign between the variables, then those variables are being related in a very specific way. They depend upon each other. So one other quick note is this. Remember before I threw in 3 for X. Well, note what that would do. That would basically mean that we would have to do a little bit of algebraic manipulation to get what Y is. We would basically have to divide by 2 and then square root both sides, and we would end up with a fairly ugly value for Y. One hint that I can give you about where to start when you have multiple variables, it's generally easiest to start with the variable that has the most crap around it. And by crap, in this case, I would mean, notice the y has the coefficient and an exponent on it, whereas the x, well, I mean, it has a coefficient, but it's a coefficient of 1, and it has an exponent, but it's an exponent of 1. So x is sort of completely bare and alone, and God, that's so sad. But x has nothing around it. It doesn't really have any crap around it, whereas y does. You should start with the variable that has more crap around it. Notice if I were to throw in y equals 2, then x becomes very obvious. 2 squared is 4 times 2 is 8, and boom, I have my x. I don't really have to do any algebraic manipulation. So if you do notice that one of the variables is surrounded by more stuff, exponents, coefficients, then I would start with that variable. So let's take a look at number 45 so we can see how this idea of dependent variables might play out in a question. This is sort of a complex equation here. We've got a bunch of different variables that are dependent upon each other, which we know because we have a equal sign between them. So this is if 3ax plus 5r over s equals 3ay, then x minus y equals. Now in terms of which variable is most complicated or has the most crap around it here, they all have some stuff around them. I'm going to go ahead and say that this 5r over s term is probably the ugliest term, so we might want to start there. So let's go left to right, list our variables. So we have an a, we have an x, we have that r, we have that s, we have another a which we don't need to list again, and then we have the y. So we've got 5 different variables here. I'm going to start with that r and that s. I'm going to make r equal to 4, and I'm going to make s equal to 2 so that that term turns into something relatively nice. 5r would be 20 over 2. So this is going to be now 3ax plus 10. Is that right? 5 times 4 over 2 is 10 equals 3ay. Fine. So it's a little bit cleaner now. 3ax plus 10 equals 3ay. I'm going to make a equal to 3. So now this is 9x plus 10 equals 9y. I'm going to make y equal to, let's do 5. We have a 2, a 3, a 4. We'll make y equal to 5. So this is 9x plus 10 equals 45. I subtract the 10, subtract the 10. I get 9x equals 35. So I'm going to get an ugly number for x here, but that's fine. 35 over 9. So this is 35 over 9. That's fine because, again, remember I have a calculator, and 35 over 9 shouldn't really intimidate me too much. So I'm going to let the calculator do the work for me. They are asking me what x minus y is, so here's my chance to go ahead and use that handy calculator. So I am going to do x, which is 35 divided by 9. I'm going to subtract out that y, which is 5, and I'm going to get negative 1.1. Oops, I'm getting some disappearing act here. Give me 1 second. Okay, hopefully that problem went away. So I get 1.11, and that's a negative, so negative 1.11. Remember, some of you might already know this, if you math enter that value, you can put it into fractional form. But the decimal form is perfectly fine here. So answer choice A, 5r over s minus 3a. 5r is 20. I'm going to do this over here where there's more room. 20 over 2 minus 3a, which is 9. So that's 10 minus 9, which is 1. That is not what we needed. We needed negative 1.11. Let's do answer choice B, negative 5 times r. So that is negative 20 over 3as. 3 times a is 9 times s, so negative 20 over 18. I think we may have a winner here, but I'm going to check it in the calculator just in case. So that is negative 20 divided by 18. Oh, it's already on there, actually. There we go. So negative 1.11. So that guy does indeed work. This guy's going to be negative 20 over So negative 20 over 18 definitely does work. Answer choice C is negative 20 over 6as. That's just going to be 2 times the denominator in answer choice B. So that's negative 20 over 36, so that definitely doesn't work. Answer choice D is negative 5r, which is negative 20 over 9a squared s. That is 9 times 9, which is 81, times s, which is 2, so that is 162. Excuse me. Getting late here. Negative 20 over 162. That definitely doesn't work. And then answer choice E, negative 10r, is negative 40 over 3a squared, so that's 3 times 9, which is 27, times 3, which is 54, and that's less than 1, so that's not going to work, and our answer is B. So again, remember what we did here. We went slowly through the variables. We started with the r and the s because that was sort of the ugliest term, and then we went slowly through the other variables. We eventually did have to use a little bit of algebra to get our value for x, which turned out to be a little bit ugly, but didn't matter. Use the calculator. Yes, this math got slightly more challenging here. The arithmetic got slightly more challenging, but trusty calculator there to help us So we got through it. Number 59, let's take a look at this one. If x equals 2t minus 9 and y equals 5 minus t, which of the following expresses y in terms of x? But remember, we want to get rid of that in terms of. We're going to go ahead and circle y. That's what we're looking for. Now, the only variable here that has some crap around it is going to be this t. It has a 2 in front of it. So I am going to start with that t. I have an x, I have a y, I have a t. I'm going to start with the t. I'm going to make t 2. That's going to produce a negative value for x, but that's fine. Let's go with it and see what happens. So if t is 2, this is 2 times 2, which is 4. 4 minus 9, so x is going to be negative 5. And then the y is 5 minus 2, so that's 3. They're asking us for y, so we're going to put that 3 in a box. Now, when we go to the answer choices, we have answer choice A, y equals 1 minus negative 5 over 2. 1 minus negative 5 over 2. That's 6 over 2, which is 3. So A works. Answer choice B is 19 minus negative 5. That is 24 over 2, which is 12. That does not work. We were looking for 3. Answer choice C, y equals 14 minus 2x, so that is going to be 14 minus a negative 10, which is plus 10. That's 24. Is way too big. This is 5 minus negative 5, which is 10. This is 1 minus negative 5, which is 6, and we are done. That was a number 59 question. That was a question that was meant to be very challenging, and we just handled it with very little difficulty using the VITA technique. Now, so this is the next page. This is page 30, I believe. Yes, page 30. There are some times where VITA is not going to be the easiest or most efficient route when you have variables in your answer choices. There are going to be certain times that VITA actually won't even work on questions with variables in the answer choices. Doesn't happen very frequently, but it can happen. So we're going to go over some of those scenarios here. This is not meant at all to detract from the power of the technique. This technique is still very powerful, but you should know some of the exceptions when the technique maybe isn't as safe or efficient as the algebraic or school method. So the first thing we have to talk about is if you clearly see that the algebra is easier and you are very confident that you are not going to make any careless mistakes in the algebra, then you can go ahead and do the algebra. However, if you are somebody that knows that you tend to make careless mistakes with algebra or tends to be a little bit shaky with the algebra, then probably you should go with the VITA. So number 13, if you want to pause the video and try this on your own with the algebra, you can. You could even try it with the VITA. This question could be solved with VITA, but you can see that the algebra, as long as your distribution skills is, or are, I should say, fairly good, we've got 5 minus 3x plus 12. I will say a lot of students do make that careless mistake of forgetting that you've got a negative 3 here and a negative 4 here, which makes this positive 12. So this is 5 minus 3x plus 12, which is negative 3x plus 17, which is answer choice A. So we can see, again, the algebra there was fairly simple, fairly straightforward. And again, if you are confident with the algebra on a question like that, then go with the algebra. Don't worry about the VITA. So questions involving polynomial factoring, you've got to be a little bit careful on these questions. Sometimes VITA will not be the best route, and sometimes VITA will not work at all on these questions. So best thing to do is to know how to deal with factors of quadratics and cubics and so on and so forth. In number 21, I will tell you, if you try VITA, you most likely will not be able to get this guy correct. So how do we factor quadratics? Well, there's a bunch of different ways. You can, if you have a way to factor these that works for you, Great. I'm going to do this one in two ways. I'm going to do it first by grouping. If you remember this method, great. If not, you're going to need to review it. We will go over this in a later section. I'm going to take the product of my a, so remember ax squared plus bx plus c. I'm going to take my product of my a and my c, which is 4 and negative 12, so that's negative 48, and then my b term is 13. What I need are factors of 48 that will add to 13, and those factors would be 16 and negative 3. I should say factors of negative 48. So 16 times negative 3 is negative 48, and then 16 plus negative 3 is 13. So I'm going to go ahead and write 4x squared plus 16x minus 3x plus the, minus the 12. Then I'm going to factor out the x from the 4x from these two guys, the 4x squared and the 16x. So that's 4x. This is going to be an x plus 4. And then I'm going to factor out a negative 3 from this guy, and I'm going to get x plus 4, and then I can see that I have an x plus 4 common to both of these terms, so I can factor that out. I get 4x minus 3 times x plus 4. Now, if this, and then I can see that my answer is 4x minus 3 because that's one of the factors. Now, if that process did not make any sense to you, like I said, you're going to most likely want to review it. And the other way that you can do this, if you do have the TI calculator, the TI calculator, TI-84 and some of the other versions of it will have come loaded with an app called Polynomial. This is called Polynomial Simultaneous Equation Solver. That's what Poly, or PLY-SMLT stands for. So I'm going to actually use that right now, and then I'll show you another program that might work. So notice number one is Polynomial Root Finder. So what I'm going to do is I'm going to go in there, order 2, that is this 2 right here. Order 2 is the same as degree 2, is the same as a quadratic equation. I'm actually going to put this on the ACT. It's beneficial to have this on complex roots, not just real roots. So I'm going to put that on complex roots. Decimal fraction doesn't really matter. That's just how you want your answer displayed. I'm going to put normal, float, degree. Those are all fine. And then I'm going to hit this graph button, which corresponds to this next tab right here. So I'm going to hit the graph button. So now you can see the app is asking me for my coefficients. A2, A1, and A0 are just the A, the B, and the constant. They're the coefficient in front of your squared term. You can see A2 is in front of the squared term, A1 is in front of the linear term, and then A sub 0 is the constant. So in this case we have a 4, we have a 13, and we have a negative 12. So now I'm going to hit solve. That's this tab here, which corresponds to the graph key, and look at that. The app gives me my two roots. It gives me my zeros, my solution. So it's telling me that one of my x's is negative 4 and my other x is 3/4. Now what do I do from there? How do I get from these roots to one of these answers? Well, I will tell you how you get from those roots to these answers. And again, this is another skill that you should have for the ACT. Most students are perfectly capable of getting from a factor of, let's say, x minus 3 to a 0 of 3, or a factor of x plus 4 to a 0 of x equals negative 4. Most students can go in the direction of factor to 0, but when students are given zeros, they sometimes have a little bit of trouble getting to the factor, but there's really no difference in what we just did and what we're going to do here. We're just going in the opposite direction. So to get from a factor of x equals, from a 0 of x equals negative 4, that would be the factor x plus 4. Going from x plus 4 back to x equals negative 4, we should be able to see that x plus 4 equals 0, minus 4, so x equals negative 4. Well, that's how we get the 0 from the factor, and we're just getting the factor from the 0 here, and this one would be x minus 3/4. Well, if you look at the answers, obviously you do not see either of those. You don't see an x plus 4 and you don't see an x minus 3/4, but what you do see is this x minus 3/4 with the 4, with a 4 distributed back through it. Again, if you don't understand the intricacies of what's going on here, we will be going over this in a later section, but you may want to brush up on your quadratics and factoring skills. So I can actually multiply this factor through by 4. So I'm going to multiply through by 4 and I'm going to get 4x minus 3, and that is actually how I produce answer choice E. There is also widely available, there is a program for your calculator called Quad Form or Quad New. This is easily attainable on the internet. Quad Form functions in pretty much the same way as the app that we just used, where we just punch in our coefficients, in this case again 4, 13, and -12, and Quad Form will produce our roots or our zeros for us. There are some limitations to Quad Form that the app we used does not have, but either one of those would work to produce zeros if you have a quadratic. Finally, if you do look at a question and you see that the answer choices are extremely complex, extremely full of variables, and in this case we have negatives and we have square roots, and you can tell that to do this question with VITA is going to take you a ton of time. The question that we did up here, number 45, also is one of those that looks like it's going to be rather time consuming. This one ended up not being too bad, but something like number 25, you most likely are not going to want to do this question with the VITA just because it's going to be very time consuming. This question, some of you might not have any problems with this algebraically. Some of you might look at it and just freak the heck out. So this says equivalent form for this guy. All this question is requiring you to do is rationalize the denominator. So if we do multiply both top and bottom by the root, by the radical in the denominator, basically what we have, sorry, let's extend that, this is going to end up equaling 5a times root 5a minus c all over 5a minus c. Remember, when we multiply one radical by the other, same radical, the radical sign just goes away, and we are left with answer choice E. So again, the algebra on this question is not actually very difficult, although some students might not recognize that the algebra is fairly simple there. And then finally, remember that if you see an I in a question, I is not a variable. I stands for the imaginary unit. That's when we're dealing with square root of negative numbers. So if you do see an I in the answer choices, you are not necessarily dealing with a VITA question. You are dealing with a question that tests imaginary numbers. So you usually cannot throw in numbers on a question that has I's in the answers. So that is it for VITA. So first of all, remember we learned the tip-off clue. VITA stands for variables in the answers. That's your tip-off clue. We learned the 4 steps that you do need to stick to on every VITA question that you do. Did some easy examples, talked about some of the additional points and additional variations of VITA. We talked about doubles, that you might get doubles, but it's not a big deal. You just got to retry. Talked about intelligent, wise use of the calculator, letting the calculator do a lot of the work for you. We talked about dependence, the fact that in some VITA questions with multiple variables, the values of the variables will depend upon each other, and therefore you have to be a little bit careful about what you throw in. And then finally, the fact that there are going to be some questions where VITA is not your best route, but hopefully those examples, those cases will be few and far between, and you will be able to use VITA quite a bit to its full extent. That is VITA.